Hey, this is Andy with another demonstration of rational systems and software engineering solutions. On today's episode, we'll be taking a look at how the Rhapsody modelling tool integrates with the Mathworks Simulink product. Systems engineers have to model many different aspects of a system. For example, the requirements of the system, the architecture, the behaviour, and so on. They also may want to verify and validate that behaviour through execution. Now, while Rhapsody is an excellent choice for most of that work, there are some parts of the model which are much better done in another tool. For example, if you have a continuous algorithm, then Simulink is a much better choice to model that piece. Now, although this presentation is going to focus on how Rhapsody integrates with Simulink for execution, it's worth taking a moment to acknowledge the other integrations between these two flagship products. This diagram, for example, shows that Simulink is great at modelling and executing continuous models. Rhapsody, on the other hand, has much better support for discrete behavioural modelling, including the token flow-based activities from the SysML modelling language. Rhapsody is better placed to model the architecture of a system and also its requirements, including traceability. Rhapsody Design Manager also allows users to review, comment, and mark up the models through a standard web browser. And so there are integration points above and beyond what we're going to look at today. For example, Simulink models can be included in requirements traceability and even browsed and reviewed using that same Design Manager tool. Today, we're going to focus on the architectural modelling, the behavioural modelling, and co-simulation integrations. There are three options. The first two treat the tools as more or less independent entities. Each one imports from the other when required. For example, you might model an algorithm in Simulink, import that into Rhapsody, and show how it fits into the architecture. If you wanted that algorithm to execute as part of the Rhapsody execution, then you would use Simulink's real-time workshop to generate the code for that algorithm, and Rhapsody would automatically include it. Alternatively, you might model a block in Rhapsody and then export that block into your Simulink model. That block would be automatically converted into an S function inside Simulink. The last approach is something we call full plant modelling. Rhapsody can be used as an architectural tool to combine Simulink models with other Simulink models, with or without Rhapsody behaviour included. Rhapsody takes your model and exports the entire thing into Simulink as a brand new Simulink model. There's no real-time workshop required, since Simulink itself is going to perform the execution. But also, if you want Rhapsody animation at the same time, then you can have it. You can get real co-simulation between the two tools. Now, working in that mode, Rhapsody can even be used as a template tool to lay out which Simulink models you're going to need and how they should be connected. Rhapsody can then generate all of those models, leaving the Simulink engineers to fill in the details. Let's look at these options actually in the tools, starting with full plant modelling. Here we have a new SysML project with the Simulink profile loaded. You can find that in the standard profiles directory. Now, in this first model, we're going to use Rhapsody as an architectural tool to connect two Simulink models together. So we'll start by creating a block, which we'll call the system. To tell Rhapsody that block will be a final Simulink model, we'll apply a stereotype, structured Simulink block. If we look at the tags for that block, we can see that there are a bunch of them we can use to manipulate that final Simulink model. Now let's add two more blocks, one called driver and another one called monitor. And we'll also add them to that the system block using composition, indicating that our final Simulink model is going to be made up of one instance of each of these. Now, if we locate these in the browser, then we can apply a stereotype to both of those blocks in one go. The Simulink block stereotype tells Rhapsody that these are not Rhapsody blocks at all, but instead they are Simulink models. Now, Rhapsody is going to ask if we want to add some default behaviour. We're going to say no, because that behaviour is going to be supplied by Simulink. Again, we can see there are a bunch of tags on those blocks now, but those tags are going to be filled in by a wizard, which we'll invoke now. If we invoke that Simulink importer, first we need to specify the location of the MATLAB executable, and then we need to specify the Simulink model that we want to import. We're going to import this simple sine wave generator. So that import is now doing its work. It's going to take a moment or two. And once it's finished, we'll see that it's going to update our block with any input or output ports that were found inside the Simulink model. And we'll do the same job for the second block there. Again, we're going to use that same MATLAB executable. And for that block, we're going to import another model, which is just a simple scope. And off it goes again, and there he is, he's finished. Now we can open the original Simulink model directly from the block that represents it, just simply by right-clicking that block in Rhapsody and asking it to show us that model. So if we do that on that driver block, that's going to fire up MATLAB, and it's going to show us that model that we've mapped that block to. And there you can see we just got a simple sine wave generator and one output port called sin out, which has been transformed into a flow port inside the Rhapsody model. Next, we're going to connect those two models together by adding an internal block diagram. We drag on both of those parts that were created on the block definition diagram, and then we can actually link those ports together. Now we can generate the new Simulink model from the context menu of either that internal block diagram or the original structured Simulink block. There are a whole bunch of options here, but we're going to choose Export. Once that's done, the output window is going to pop up to keep us informed. So there you can see it's exporting the Simulink model. And again, that's going to take a few moments. There he is. Simulink model has been completed. The update's been done. We can now switch over to Simulink and see the results. Now firstly, we can note that the new Simulink model reflects the layout of the items on the internal block diagram. You can see that first submodel there is indeed the sine wave generator that we pointed at, and the second one is a simple scope. We can now execute that entire new Simulink model, and when we do that, we should of course see our sine wave come out. So let's flip back to Rhapsody and make a change. It's going to be a simple change to start with. Let's go back to that structured Simulink block and open up the tags. And here we're just going to change the stop time of that simulation from the original 10 to 20. Now, having made that change, we can then re-export back into Simulink. This time we'll do it directly from that structured Simulink block. So there we go, we're going to say export. Now once again we'll keep an eye on that output window so we know what's going on. Well, this time it's a lot faster. Now we can switch back over to Simulink and execute that again. And of course when we do that, we should see the output of that scope change to reflect our new setting. This time we're going to make a bigger change. We're going to replace the simple sine wave generator with something else, a Rhapsody block. We'll create a square wave generator. Now obviously this is just an example of how the integration works. If all you wanted was a square wave generator, then you'd pick one from Simulink. Let's delete the driver block completely, along with any instances of it. And we'll replace it with a new block. We'll call that generator. Now in order for our generator block to communicate with the monitor, we're going to need a flow port. To make our life simple, we'll copy the one from the monitor. Now the one on the monitor is an input port typed by a reel, so we'll duplicate it just like that in the browser, and then we'll change its name to something a little more appropriate. Let's call it OP, and we'll change that from an input port to an output port. What our block also needs is an attribute with the same name and type as that port. When that attribute value changes, Rhapsody will automatically propagate the new value through the port. So let's add a new attribute to that block called OP, same name as the port. with the same basic type. Now, of course, we can choose to show that attribute on the diagram using the standard display options. Now, we're going to add an instance of that block to the structured Simulink block using the part association or composition connector. Now, to make sure that those two pieces actually communicate, we'll connect them together on the internal block diagram, just as we did previously. So we'll drag on the part and we'll wire those ports together. Now, the only thing left to do is to add some behavior to our new generator. In this case, we'll just use a simple state machine. To generate our square wave, we're just going to need a couple of states and some transitions between them. Just like this. Now, our first transition is going to be triggered by a time event of, let's say, 1000 milliseconds. When that transition occurs, then we'll set the value of that OP attribute to 2. When that value is set, that will automatically propagate through the port along the connector into the scope model. The other transition is going to be exactly the same, except of course we'll change the OP value to something else. In this case, let's make it -2. So there we've got some simple behavior. Now we can go ahead and export the entire thing to Simulink, just as we did before. The only difference this time is that we'll choose export for animation. Now all that means is that we can see the simulation in Simulink, just as before, but also in Rhapsody. Now that's just an option. We could have simply exported it into Simulink and executed it there. But by choosing animation, then we can actually see the animated versions of the state machines, sequence diagrams and so forth inside Rhapsody, and of course we can control it from inside of Rhapsody. So our export's taking place. There it is, it's finished. That means we can flip back over to MATLAB into Simulink just as we did before. And we can see our Rhapsody block there has now become an S function automatically, and it's wired up into that scope model. If we open up that scope, of course we can see the results of that execution inside Simulink. Now we'll just shuffle a few windows around so that we can see Rhapsody and Simulink at the same time. Now this time, when we execute inside Simulink, the animation bar inside Rhapsody is going to pop up. And there it is. Now we can just click Go to see it execute, and straight away we can see that square wave in the Simulink scope. Let's try that one more time. We'll click Go inside Simulink. This time when our animated bar comes up, we'll fire up an animated version of one of our diagrams. Let's pop up a state machine. And we'll put a breakpoint on that state so that whenever we enter that state, it's going to break. And now we can see inside Rhapsody we've got the animated state machine. We can click Go and Go and Go, and then you can see the square wave constructing itself as we do so. What we're actually doing here is co-debugging both of these models. The last example we're going to look at is a little more involved. We have several Simulink blocks communicating both with each other and also with some Rhapsody blocks providing some control. If we execute this model, then you can see that we have a Rhapsody panel diagram with some dials and LED displays and so on, and these are bound to the values coming from the Simulink models, giving us a very nice mock-up with some real algorithmic behavior behind it. With Rhapsody's integration with Simulink, you can choose the right tool for the right job. You can model architecture and discrete behavior in Rhapsody and combine it with algorithmic modeling done in Simulink. That's all we have time for today. Thanks for listening.